Hello everyone. In last week's video, we used a single input parameter to drive the entire geometry of a subassembly. So we selected which curve design based on the pull-down menu or a selection for the user. Today I wanted to take it a step further, and instead of using a single parameter, I want to use multiple parameters to drive the geometry. In this example, I'm going to use a excavation or a trench for a pipeline. So let's assume we have the center line of a pipeline geometry, and we'd like to define the trench box size using a width and a depth parameter. First things first, I'd like to give credit where credit is due, and I'd like to thank Peter Funk from our product development team. Peter assisted me with getting me over the hump with a few of the input parameters you'll see later. We'll talk about those as we get to them. So let's get started. I'm going to start with a target parameter first, and I'm going to call this EG, just a surface target. We always need that. Next, I'm going up to View, Define Enumeration. The first one's going to be called Trench Width, and I'm going to create 3 widths. Let's do a 24-inch width, call it D24. A D36 inch and a D48 inch, and I should be doing W instead of jumping ahead of myself here. W36 and then a W48. That's my 3 choices for width, and you can have as many as you'd like. So one trick here, I need to hit OK and come back to the command if I want to build a second group here. You can't really, it doesn't like it when you want to try to build 2 groups in the same setting there. So I'm going to go do the depth now. I'll call it trench depth, and now we'll do D24 for a 24-inch depth, a D36 inch, and a D48 inch. Remember, those show up as input parameters, so I'm going to create an input parameter called trench width. The name of this will be width T. Notice our choices here under the default, they're already showing up. I'm going to create another input parameter for the depth, and we'll just call this depth T. Make sure these show up. They are my defaults, so we're good there. And let's change the subassembly name to trench tester, and I'll go ahead and save this to the disk as the same name just to keep it consistent. Go back to the input parameters. Now we're ready to get started. Just like last week, we're going to start with a switch. I'm going to go to the expression of the switch, and we need to use the name, again, remember from last week, the name of the input parameter, not the enumeration. So it's going to be width T dot value. That's going to tie it together so that I can select these through the geometry. So width T dot value, there we go. And I'm going to use sequences to group this just for ease. You don't have to, you can put them all on one sheet here, but I like to group these together. And I also like to name these so it's easy. If somebody else comes back on my work, they'll know what I was doing. Click the switch and then the arrow. I'm going to turn off default, and this is where you have to set the name exactly right. W24, this is what ties it to that input parameter. So when I'm in a 24-inch width, what do I want to do? Well, I want to go into the sequence, and let's place a surface link. We're going to call it L1 every time. EG is our surface. Since it is a 24-inch width, we're going to do a -1 and a +1. I'm going to do fit to screen. What that does is says, okay, the center line's in the middle, so I'm going to go -1 foot over, 1 foot in the other direction to get a 24 or 2 foot wide box. You can see I have P1 on the left, P2 on the right. I like that. So we're done with that sequence. And just quickly, just to show you, I will do the next one the same way. Delete that. Drag here. Select the leader, turn off default. That'll be the W36. That has to match. W36 here. Again, trying to speed the video up a little bit. Double click, surface link. That'll be L1. Notice I'm keeping my names consistent. EG. For 36, it's going to be a -1.5 and then a +1.5. Here I want to use P1 and P2 again, so I'm consistent all the way through. Make sure it's working. I'll flip my default and then hit fit to screen. Notice it is red. That means it's working. If you do that and it's not working, that typically means your switch, you've got a messed up expression here, or you forgot to name your leader lines or your connectors to match exactly these values. Okay, so now we'll do another sequence for 48, and then I will be finished with the widths. Now let's go to the depths. Well, I want to add another switch. This is kind of what's different from last week. So what I would do is I would funnel all three of these widths through this second switch. At a 48, it would come right here. Click on the second switch. Now we're going to tie to the depth. Remember, it's the name, depth T dot value. Depth T, input parameter name, has to be that, not the enumeration name. So we'll scroll down, and we will create a sequence here. I'll do one of these, select the switch, then the leader, turn off default, just like before, D24. Exactly the same. I would probably name this D24. That doesn't have to go, but double click on the sequence. Now I need to work on the depth. I'm going to place a point under point 1. Again, I'd like to thank Peter again for helping on this piece. But I want to go down at the 2 foot or 24-inch depth. But what I want to go down from, I want to maintain a minimum 24-inch depth, because remember, this is a surface link and it's just going to lay on top of the slope. So I want the lowest or the minimum offset to be the point at which I go down my depth. So what I'm going to do is I'm going to go to my delta X, set that to 0 because I want to be directly under P1. So I go from P1. And then for the Y, what I'm going to do is I'm going to say, okay, link 1, that's that top link that's on the surface. Give me your minimum Y from the origin and subtract out the Y location of P1 that gets established. So what this does is drops it right on top of P1 basically, or whatever right now it's here, but it would be the low point. So that would find the low point, whatever offset, because it's from the origin. So the minimum of L minus the Y offset of Y. And then all I need to do is put some parentheses and subtract out my 2 feet. Let's fit the screen. We can see this is working. Looks promising. So we can go ahead and add a link here. That's L2, that's fine. So we'll finish up this one. We'll add a link from, I'm sorry, we don't need that yet. We need another point on the other side to go underneath P2. So what I'm going to do in this case is we're going to go from P3 instead of P2 this time. So in the Y, we're going to leave that to 0. But for X, what we're going to do is take the X of P2, subtract the X of P1. Because remember, these are offset X from the origin. As soon as I hit tab, fit the screen, you'll see P4 show up in the appropriate spot. Okay, now I'm going to add some links. You could add it there, or I like to add from the top, so I'll do P2 to P4. And then I'll add another link from P3 to P4. And what I would do is make note of all these link names and point names, so I would keep these exactly the same in all the sequences. Now I'll drag my shape in so I can do a volume, click the green arrow. Now I have a shape code so I can do volumetrics. So now I'm finished. So now I would do the same thing. I would do a sequence for the 36-inch depth and the 48 the exact same way, just subtracting on that. When we get to P3, I will subtract 3 feet and then 48 inches respectively for those two. And then it would be finished. So I'll go to the finished example where you can see that. So there's the 3 that we did at the top for the width, and we'll go to the depth for 48. You can see D48 through the switch. So there again, same thing for P3, L1 min Y minus P1Y minus 4 foot to get us down to 4 foot. And then P4 comes from P3, P2X minus P1X. So let's go to the 36-inch, just so you can see all these names are the same. P1, P2, everything's the same in all 3 of these. So it's really consistent. So I save that now. Now I'm ready to test it in Civil 3D. So I'm going to import Subassembly right onto the tool palette. There it is. I'm going to refresh the image with a right click. Now I'm ready to place it. Left click, drop it here. Notice you can see the default must have been the 48. Let's select it and go to properties, double check that. So our default was a 48-inch depth and the 24-inch width. So let's rebuild the corridor, right click, properties, set all targets to my OG, okay, and rebuild. I want to right click on the corridor, rebuild automatic. So these cross sections are 1-to-1 on the right, so let's check some distances. It should be about 2 foot, and it is in the X, and it should be from this minimum point here, the lowest point of this link, it should be 48 inches or 4 foot, and it is. So remember, this link lays on top of the ground. It finds that minimum, the lowest Y, and forces a 48-inch excavation down from that lowest point, so you'll have more on the other side. So let's test some other depths. I go to the subassembly properties, and I'll do a 48-inch wide, and I'll do a 24-inch depth. Okay, again, if I do my distance, got a 4-foot depth and a minimum 2-foot, width. And then from here up, I should be at 2 feet, and I am in the depth department. So my goal today was to show how you could create multiple parameters within your subassembly to drive multiple variables within the subassembly geometry. I hope this has been beneficial. Have a great day.